So welcome everyone. Thank you for joining the session. I'm Yassine Elqandili from Accenture, Belgium, and I work there as a technical lead. I'm also a certified application architect and heading for CTA, hopefully, in the future. So what are we going to be talking about today? This is our agenda. First of all, this will not be a very technical session. We will mention Salesforce DX in a few attempts, but it will not be a very heavily technical session. So this session will be mainly about why do we need continuous integration, continuous delivery, and what it is already, and how to do it in a customer context. I mean, what are the topics that we should tackle with the customers. So in the how part, we will see the sandbox strategy, the delivery pipelines that are possible, the branching strategy for your repository, and then we will highlight what Salesforce DX does and how it will help you deliver what we want to achieve with continuous integration and continuous delivery. Okay? Am I audible for the people in the background?
Now, yes.
Okay, so I'll put this. All right, perfect. So first question is why continuous integration and continuous delivery? So not only in the world of Salesforce, we all know that deployments are a hassle thing to handle within a project. So there are always errors, there are always last minute things that we need to check, like test classes, things that we realize at the end of the process of delivery. CI/CD comes to resolve that issue. It's actually there to help you detect issues earlier in the process and then fix them, because you will have your developers all working together within the same environment continuously. So now, what is CI/CD and how it will help us to do that? So CI, which stands for continuous integration, it's actually the process of continuously and automatically merging changes that are done by the developers into one single source of truth, which is your repository, code repository, your version control system, which might be Git or other VCSs. And then test them and deploy them automatically to the next environment where they can actually coexist together, so that you can run your integration tests on them. So you have multiple developers working on different features. They will all coexist in one environment automatically thanks to continuous integration. Okay? Now, it will cover the 4 points that we see here. Let me just put the laser on so that I can look at my screen. So you have the build part. That's when the developers push the code and it triggers automatically a build in your CI pipeline, your continuous integration pipeline. Then it runs automatically the unit tests to see if there are any errors. And then it will deploy to a staging environment so that your acceptance testing can run. But the deployment is actually done manually, okay? Now, continuous delivery or deployment, because CD stands for both actually. So continuous delivery takes on when continuous integration finishes actually. So it will deploy to higher environments like UAT or SIT or production or your training org, okay? So, and that will help you to do deploy to your QA environments, all of those that I talked about, and also deploy to production and training. The only difference with continuous deployment is that in continuous delivery, you have a manual action, meaning that a human being will go to the system and click deploy, and then it will trigger a deployment. Now, for the how part, you need to focus on 3 main steps. So actually, and a lot of your time will go into the first step, because that's where you need to adapt your strategy to your customer perspective. So the first step is aligning. That's when you align your business objectives with the technical implementation. To be honest, technically things are not super difficult. It's always putting the technicalities in the customer context, which makes them generally more complicated. So this first part is really important and crucial for your success for defining your strategy. So with aligning your business objectives with the technical implementations, I mean that you need to understand business need to achieve with agility? Meaning that do they have release cycles? Do they go for a feature-based deployments, meaning that for each feature that is finished, it goes to production? Or you take a batch, meaning a package of features that all go together in a 4-week sprint or something like that. You need to also understand who are the teams that are working on that project. So if you have multiple teams working, multiple projects running in parallel, you need to also understand that. You need to understand how do they work in order to come up with a common strategy, because it's really important that everybody works, all the teams together work in the same code repository. Otherwise, it's not going to work. And then you need to create a repository of existing tools. Okay, so your customer might have a set of tools that they use. They might have some guidelines that they already have defined for other IT systems that you need to also align to. Like having Azure DevOps, for example, or having other Microsoft or code repository tools. So that you need to make all of this. All of this to have a common understanding across your business for what are the objectives and also what are the responsibilities. Okay? The second part is design. Design is there where you design your deployment flows and release cycles to respond to those business challenges that were identified in the first part. So you will need to see if it's a feature-based, then you need to go each time a developer pushes something to the repository, you need to deploy it right away. So there you need to have a different automation than when you have a full release pipeline. I lost my... 1 second. Oops. Okay, doesn't matter. And then you need to make a choice of the tool stack. So your tool stack will depend also on the first part, because your customer has his tool stack, and you will come up with your own tool stack as well. And with the tool stack, I mean from the very beginning, from what the developers use, like IDEs, to what are the CI tools that you want to use, Jenkins or Travis CI or other things to everything. Once you have that ready, then you can go to the third part, which is I consider as the easiest part. It's also technically complex, but then you're in your own corner and you can make it right. And then technically implement and document the solution, which is also important. And the second part is to train your team to do it, because you might have the best tools ever. If your developers are not ready to use them, it's not going to work. It's going to fail for sure. So you need to train the developers, and they need to ask the right questions. And you also need to allow some time for them to get used to the system, to the new way of working, actually. Okay, so now let's move on to how to do it from a sandbox strategy perspective. So generally, you have multiple developers. Excuse me. Generally, you would have multiple developers working on different dev sandboxes who commit and push their code to a common repository, which might be Git or other things. And then that's when the CI part or the CI server picks up the code and deploys it to a CI integration sandbox. That's the part where all the features from the different developers will coexist, okay? And so you see here as continuous integration, that's build, unit test, and integration. And then comes the continuous delivery. That's when a human being goes to the CI server and say, deploy to production or to QA or to higher environments. And here it doesn't include, of course, the CI because the CI sandbox, because the code is already there. Okay. Now with the new way of working with Salesforce DX comes to replace actually dev sandboxes. Why? Because actually sandboxes are very limited. Companies don't have enough. Sometimes they don't have enough sandboxes to cover for all the developers that they have. So sometimes you have to have multiple developers working on the same development org, which might lead to other types of issues. And they get outdated, and they take time to refresh. So all of those challenges make them hard to use development sandboxes. Now, Salesforce DX comes with the Scratch orgs. Don't know if it's there already. No. So it comes with the Scratch orgs, which are actually, you can consider it as more of the developer's own local development environment. So it's an environment created from scratch from Salesforce. It's very fresh, where the developers can go to and just do their work for that one feature, and then they will destroy that Scratch org once they are done with it. And that's very important. So all of your development sandboxes will be changed by using Scratch orgs for each feature. And then your CI server will actually create each time it wants to deploy a feature in the same type of Scratch orgs that the developer has done his work on it. So that's actually minimizing the risk of having other types of errors of mismatches between different environments. Okay? And of course, in that Scratch org, you will have the common code from different developers, which is also important. There's also the part of the hotfix that I didn't talk about in the very beginning, and that will also be a Scratch org that you will create from production to fix to do the quick fixes for the defects that you get on production. Now with the QA sandbox, that's another complicated part where we'll need to see what are those QA sandboxes, because obviously it's not going to be one. It depends on from one project to another. So this is what we're going to see next. So that's delivery pipelines. So in smaller projects, like less than 5 people, you don't need multiple environments. You can, less than 5 users, I mean. You don't need multiple environments. You can just use one sandbox, so development, UAT, and then production. But then for most of the parts, you actually need more environments to do your integration testing by your own functional people first, and then deliver to the customer to do their own acceptance testing before going to production. That's a second option. And there are also other more complicated options where you have, or more sophisticated, I wouldn't call them complicated, where you have development and then merge, where all the code coexists, and then there would be an SIT where you do your actual testing by users, and then UAT where the actual end users will use it, will do their testing, and then it might be that you need performance testing because you have some heavy batches or heavy code that runs in the background, and that you need to do some performance testing on it. And then you might also need a pre-production system, and that would be staging, and then production. So these are different sets of configurations that you might want to have, but keep in mind that it's just examples. It really needs to stick with what your customer needs. So for example, you don't need performance testing if you don't have like heavy processes. This can be really switched and tweaked to your own needs. And that's the QA sandboxes part, okay? Now we're going to see how do we do that from a code repository part? How do we do our branches? So ideally you would have master QA, which will be as many as environments as you have, but here for the sake of simplicity we'll have only one branch for QA. You would have develop and then feature branches. So once your project starts, you have your master branch, and that's your code that you get from production. Okay, because in the beginning, your production is your source of truth before putting it to the Git repository. Once you put it to the Git repository, your single source of truth should become the repository itself, not the production org, not the development sandboxes or Scratch orgs, nothing else. It should be really your Git. Okay, and then you will check out that code from master to a branch that's called develop, and that's where all the code of different developers will merge into during the development process. So that, let's take, for example, developer 1 works on feature 2. He will take the code from develop. He will do a bunch of commits, 1 or 2, and then pushes back to develop. Okay, so pushes back to develop is not actually a push, it's actually creating a pull request, and then there's another person who oversees the whole application who will actually approve your change request, and that's generally a release manager. Now, another developer is working on a different feature, will check at another point of time. So you see the time here is different. Will check out of the develop and will put his develop his feature and push it back again to develop through a pull request. And as you see here, the icons appear. Here, the CI server will trigger automatically the creation, the build, test, and deployment to that Scratch org of where everything is merged. Okay? And then once we're sure that everything is okay, we can move to higher environments. Okay. To the QA environments. So that could be UAT, SIT, production, training, and different things. And then once we're sure that our feature is working, the customer has approved it, we can deploy it to production. And here, what makes it actually easier is that everything is automated. It's just somebody who clicks on it if it's continuous delivery, which I recommend to avoid having something that you don't want go into production. So it's just a click. It's not somebody doing actually all the work behind. All right, so the third and last part is the implement part. That's where we're going to talk about Salesforce DX, Salesforce CLI, source format versus metadata format, and then an example of tool stack. So Salesforce DX is a Salesforce product from the App Cloud that helps you do your development, as I said, in a good way, because everything that I just stated was possible before, but it was through development sandboxes, metadata API, and there were a lot of complications behind it because it was actually using sandboxes and concurrent developers working on the same things. Now, Salesforce DX comes with a new approach of source-driven development, which is a new project structure, I would call it, that allows you to have small subsets of files that are more readable and more understandable by a human being than the big files, the metadata files that we used to have before with Metadata API. The fact that we're using Scratch orgs is one of the best things that I could dream of, because when I started in Salesforce, I started from a web development environment where I had my local environment. So when I started Salesforce, it was kind of weird to work with other people in the same sandbox. So I had that challenge, and now it's possible, thanks to Scratch orgs, to have your own temporary org. And then you have the enhanced CLI with each release now. Salesforce are putting a lot of effort to provide more flexibility with the Salesforce CLI. And then you have the IDE's integration. I like Visual Studio Code, although I'm not a fan of Microsoft, but this one is a good product of Microsoft. And then it allows you to have continuous integration more easily than before, because now with the Salesforce CLI, you can automate a lot of things that you weren't able to do before. And then reimagined packaging. Salesforce DX also comes with an org development model and a package development model that we will not talk about today because it's another complex story. But it's just say it as a new way of packaging your code into different packages rather than just putting them into one single batch. And then pipelines for continuous delivery and partial and the use of sandboxes as before. That's no difference. Now, Salesforce CLI, it's a powerful command line tool that this is a copy paste from Salesforce, by the way. So it allows you to perform commands against your Salesforce org, sync code from your org, create and manage orgs, like Scratch orgs. This is one of my favorites, which is import and export data, because before in sandboxes, if you create a new sandbox, you need to inject your new data somehow, data loader or or create them manually, which makes it a hassle. Now with this, you can just have your data files within your repository as well, and with a single line of command, you can just inject the data once the Scratch org is created. So that all the developers have some sample data to do their testing, to do their development. And something that you can also enrich while doing your work. And then you can create and execute tests from the command line as well, and then create and install packages. Now, an example of metadata format versus source format. So this is the old way of working where we used to have, for example, just for objects, one file for all, for everything related to that object, including list views, fields, and everything. Now, translations also. Now, with the new structure, you have the fields in one folder, and each field has its own metadata file. List views, translations are there separately. So you really get to have less impact on an object if you just touch one field, for example. So that's having less impact on the whole team. You can understand it a lot better. You can find things a lot easier because if you want a list view before, you need to go to the big file and then look for that list view. Now you just go to that objects folder and then list views and then find it. So it's a really, really useful tool. Now we're going to talk about Visual Studio Code, which, as I said before, I really like. So Visual Studio Code is free and open source, so you don't have to have any licenses. I think there is something to use licenses, but you don't have to. And then you have a lot of Salesforce-supported products or extensions, like the Salesforce extensions, which installs CLI, Apex, and Apex debuggers to be able to debug Apex from your IDE. And you will be able also to create Lightning Web components, Aura components, or Visual Code from your IDE without going back to Salesforce and then back to the IDE. And another extra one is that I really like is Git Lens, because it supercharges your Git to a point that you can go to a line and see who committed that line at which time without having to go through all the commits in your code repository. So it's a really a good tool, Git Lens, to also have, because it helps you to actually blame who made the actual mistake. Okay, but for the CI tools, there are endless possibilities. You can use whatever tools you want, like Travis CI, Git, GitLab, Jenkins, Bamboo. For our customers, some of them we use Azure DevOps, which has everything from pipelines to Git to actually doing your user stories, so everything stays in one place. You can use GitHub. The possibilities are endless. Now with Salesforce DX, it's really handy. And all of this is to actually achieve happiness. This is a movie that I really like, and I wanted to incorporate it into this slide somehow. So all of the CI/CD strategy that you will put for your customer will help your development teams, because they will really work and focus on bringing business value rather than spending time debugging other errors that you discover late in the process. The functional team is happy because they test things that work because developers had more time to do it. The product owner is happy of his new product because everything is integrated and delivered fast as well. Because, as you know, deployments take sometimes 2 hours to 1 day to 2 days if it's not automated. So now with the automation, you can win big amounts of time and a lot of happiness that you will achieve. And happy sponsors and stakeholders, because the deployment issues are, I know that they escalate also quite quickly at the customers. So if you don't have to have that pain anymore, that's also something good. And they are happy because the quality is also good. And the two last most important things is happy users who will use your Salesforce, and happy customers to whom you are delivering that solution. So with that, I would like to thank you. And if you have any questions, please don't hesitate. Thanks.